Okay, we're on example 2 on page 293. So this is like part 2 of what we started yesterday. We're going to use identities to simplify the expression. Okay, so this was the part that I was saying that I like to do because it's kind of a puzzle and you're just going to simplify this equation. Okay, but before we do that, we have to do the crummy part, which is determine the non-permissible values in radians of the variables. Okay, so we need to figure out what is going to cause a restriction here. Okay, so when we're talking about cotangent, that's like cotangent is 1 over tan, and tan happens to be sine over cos, right? So if we're talking about cotangent, we're actually talking about cos over sine. Okay, so if we look at our unit circle, we want to see where cos over sine would give us something that's undefined. Okay, so if we're looking on the unit circle, if you look at pi on the unit circle, that would be where cos is -1 and sine is 0. So that would give you like a -1 over 0. That's bad. That's undefined, right? So this would be part of the restriction. Okay. If we're looking at cosecant, cosecant is the same thing as 1 over sine. Okay, and we need to look at the unit circle. Where is sine 0? Because where sine is 0, that's going to make a 0 in the bottom. Yeah, so it would be pi again, right? 0 and pi. Okay, so pi again. And then if you look, cosecant times cos, if those multiply together and give us a 0, that's bad for the denominator because that makes it undefined. Okay, so where is cos 0 on our unit circle? What was that, pi over 2? Okay, pi over 2 and 3 pi over 2. So every half a pi, basically, right? Okay, so if we want to combine all this stuff that we're saying here, all we have to do is say our restriction is going to be pi over 2n, because if this is pi over 2 and n was 1, it would be pi over 2. If n was 2, then we'd be at pi, which is also a restriction. And if we were at 3, then we'd be at 3 pi over 2, which is also a restriction. So by just saying this, it compounds and makes all of these restrictions just into one little section. Okay, so now we are going to simplify this expression. So all this means is we're going to make it as easy to look at as we possibly can. Okay, so right now it looks crazy because it's cot x over cosecant x times cos x. And the x's really don't mean anything. They could be in the angles. We're not worried about them. Okay, so what we're going to do is we're going to simplify this down so that it's something easy to look at. Okay, so what we use is we use our reciprocal properties or our other properties that we've talked about. So remember when I told you to write them on a sheet so that you have them? This is when we're going to use them. Okay, so is there something we could switch cotangent out for? And it might be more and it might make it look more complicated, but eventually we might be able to reduce this down to something simple. Okay, so cotangent can be written as cos over sine. Okay, so all I'm doing is replacing cotangent with cos over sine. Okay, so that is now the top. Okay, can we replace cosecant with something? How about 1 over sine? Okay, and then we still have this cos multiplying to it. So if you think these two are multiplying together, okay, so if we want to simplify the bottom a little bit, 1 times cos is cos, and then you still have sine in the bottom. So our top is now cos over sine, and when I multiply the bottom, I end up with cos over sine. Okay, because all I did was multiply 1 over sine times cos. 1 times cos is cos, and you have sine in the bottom. Okay, so now we have cos over sine divided by cos over sine. And what is that? It's 1. Right, because 4 divided by 4 is 1. Cos over sine divided by cos over sine is 1. Verify that the equation cotangent x plus 1 is equal to secant squared. So we're going to verify that it is true, that is a true statement by using this. Okay, and I still think Tessa's way was easier because we're dealing with cotangent and tangent. So if we switch that to a degree, so even looking at your unit circle, what degree is pi over 6? Or if we needed to change it, we would multiply by 180 over pi. And the pi's would cross. We go 180 divided by 6 is 30. Okay, so we're talking about a 30-degree angle. Okay, so that means we're talking about this special triangle. And how does it go? 1, and then 3? Oh yeah, right. Square root 3 and 2. Okay, so this is our special triangle. If we wanted to see, okay, so what we're doing essentially is they're saying x is this pi over 6. Okay, so if I was writing the equation, pi over 6 would go in here where that x once was. Okay, so this part we can figure out what cotangent would be. Okay, because cotangent's the opposite of what tan would be. So if we're talking, remember this was 30 degrees, this radian here. So if we're going from the 30 degrees and we wanted to know what tan was, he's opposite over adjacent. So he's 1 over root 3. So what's cotangent then? Root 3 over 1. So just root 3 essentially, right? So that means this is actually root 3 squared. Okay? And I forgot to throw my pi over 6 over there. Okay, so we'll deal with this side and we'll get an answer, and then we'll figure this side and we'll do that. So we'll go left side, right side. Okay, so this cotangent squared at 30 degrees, cotangent or tan was 1 over root 3, so cotangent is root 3 over 1, which we're just writing as root 3. And since he's squared, the square of a root is just going to be 3. Okay, so we don't want to forget we still have this plus 1 here trailing along. So our answer at the end is 4. Okay. And so now we look at the other side, and again, this pi over 6, that's still 30 degrees, but we're talking about cosecant, which is the opposite of sine. So we're going to go opposite over hypotenuse, which is actually going to be hypotenuse over opposite when it's cosecant. Okay, so if we're talking sine and we're going from the 30 degrees, opposite is 1, hypotenuse is 2. So it's 1 over 2. So cosecant's going to be 2 over 1, which is just 2. And so this whole chunk turns into 2 squared, which 2 squared is 4. So now we've just verified that pi over 6 is a solution to that equation. Okay, so for part B, it says use quotient identities to express the Pythagorean identity. So this is the Pythagorean identity that we talked about. Okay, we wrote that we wrote it on our sheet yesterday, and I just wanted to show you where it comes from. If we were talking about our unit circle, and remember how I always said it's called a unit circle because the radius is always 1 unit out. This is 1. Okay, and this is our sine. This is our cos. Okay, so, or is that, no, sorry. Do I have it backwards? Cos and sine? This should be our cos because it's first in the ordered pair, right? So it's representing the x's and sine. Okay, so if you think about our unit circle, how it was like this, if you think about the Pythagorean theorem is this side squared plus this side squared equals the hypotenuse squared. So we're writing it as cos squared plus sine squared is equal to 1 squared. And that's where the Pythagorean identity comes from. Okay, so what the question is asking us is, they want us to show that this identity is equal or equivalent to this one here. Okay, so essentially we're taking this one and we're changing it into the second one. Okay, so we have cos squared x plus sine squared x is equal to 1. Okay, so what we are doing is, it says we have to use the quotient identities. Okay, so the quotient identities were the first ones that we had. And they say that, but they're using the reciprocal ones. Okay, so if we manipulated this equation a little bit, say we minus sine squared over, because as long as it's mathematically correct, we can change these how we want. Okay, so, oh sorry, do I want to multiply? Oh, hold on. I'm going to start my equation. Cos squared x plus sine squared x is equal to 1. Okay, and so what we're going to do to manipulate this equation is, if cosecant is equal to 1 over sine, you can say that cosecant squared is equal to 1 over sine squared. Okay, so let's multiply each of these pieces by 1 over sine squared. So then this piece is multiplied by 1 over sine squared, and this piece is multiplied by 1 over sine squared. Okay, I'm choosing that because I'm trying to, do you see how we have a cosecant squared and some stuff in there? We need to try to bring it in because we're trying to change the equation to that. Okay? So if I multiply each of these pieces by 1 over sine squared, that means cos squared times 1 over sine squared is cos squared over sine squared x plus, and if we have sine squared times 1 over sine squared, it's like sine squared over sine squared. And 1 times 1 over sine squared is just 1 over sine squared. Okay, now we can simplify these ones, because cos squared over sine squared is going to be the same thing as what? Cotangent squared, right? Because if cos over sine is cotangent, cos squared over sine squared is cotangent squared. Okay, we needed a cotangent squared, so we are good, right? Sine squared over divided by sine squared is like, what's that? Oh, the x, yeah. We're trying to change this equation, remember, into this one. Okay, so then sine squared divided by sine squared is 1. And what is the same thing as 1 over sine squared? Cosecant squared. Okay, so we changed our Pythagorean identity into this other identity that's equivalent to it.